we're going to start off with the impact of security by default. Security by default, I'm sure most of you know, has been introduced by Cisco on version 8 and above, and it was probably something that was needed for quite a while. Security has always been a major importance to most enterprises, and before version 8 and before security by default arrived, then there was some holes in some people's IP telephony systems. These can all now be closed, and it can be made very secure. However, it is very important you understand how it does that and what the impact of the application of security by default is on your system. So we're going to really focus on that today, and we shall be showing a little bit around our product, which shows you how to manage some of these issues and some of the advantages you get through the additional security using our tool. But just first, before we hand you over to your esteemed speakers and I introduce you to them, just a few house rules and information for you. The session will be recorded, and if you wish to get a copy of that recording, then please do email the address shown on the screen just now, sales@unifiedfx.com. And however, if you have questions during the presentation, please do feel free to ask these on the Q&A box that is provided in WebEx. And can you please ensure that you submit the question to all panelists, because some people will be speaking and some people will be able to answer your questions during the other person's session. So therefore, we'll try and answer as many as we can as we go along. However, if there's any left, we will review them all at the end and make sure they cover them off. Okay? Okay, so let me just introduce you to our speakers. We're absolutely delighted to have two fantastic speakers for you today. The first one is Akhil Bell, and he is the leading security expert on IP telephony within Cisco. He literally is the person who wrote the book on it, and if anybody has our products, you'll notice that in the reporting we've collaborated with Akhil to produce a report that gives you all the information that you need around the security requirements and security parameters within the Cisco system. Now, they're all taken from Akhil's book, and it was after reading Akhil's book that we decided to add this functionality because we felt it was so important. So it's absolutely fantastic that we've got Akhil joining us today. So Akhil will be telling you the theory and around the new security by default and how it works and what you need to look out for. And Stephen Welsh, our CTO, will be giving some reflections on some of the many installations that he's worked on where he's used our tool to rectify, identify, and manage the security aspects of the IP phones. So we'll be giving you a bit of education, and then we'll be following it up with a little demonstration on a live system. Okay, and Stephen was also the original author of our phone view product. So you're in very good hands today. So on to the agenda. As I was explaining, there is a number of different parameters and changes and issues that you may find around security within the Cisco IP system. However, if you get them all right, it does make the system extremely secure and very compliant. So therefore, we're going to take you through each of the sections. The first section here will be handled by Akhil, and then when it comes down to common issues, recommendations, and useful resources, we'll hand over to Stephen to make those for you. Okay, and Stephen will do the little demo. And of course, we'll try and leave some time at the end to answer all your questions. But please do ask the questions as you go along. Okay, I'll now hand over to Akhil, who will pick up and tell you the detail of the session for today.
Thank you, Andrew. So welcome everyone to the session. Myself and Stephen will be steering from here on. So we'll start with the basics of what exactly is security by default, which is the crux of this session. So security by default is a wonderful feature which was introduced with CUCM 8.x, and ever since it's going to remain for all the later versions. So it is right now in 8.0, 8.1, and then in 9.0, 9.1, and so on. So any future release of CUCM you're working with, you'll have this feature in there by default. So what exactly is it doing there, first of all? Why Cisco decided to have security by default in place at all? The reason behind that is the initial installation of any CUCM cluster by default used to be unsecure. That is, unless security using CAPF, or in other words, the Certificate Authentication Proxy function, till the time that was enabled, there was no way for the phones to trust their call control and vice versa. So Cisco thought, why don't we have a preliminary control in place which can help prevent the spoofing aspect of, well, I'll talk about a bit about different attack vectors. So there is spoofing, then there is identity theft, that I can register with another phone's MAC address on my PC, emulating it as a phone, and then there goes everything out of the window. On top of it, there are rogue phones which must be dealt with, which are not part of your environment, but then they imitate to be. So essentially, Cisco thought, why don't we have a preliminary security control in place that the endpoint can trust the call control and the call control can trust the endpoint? And that was, of course, to be based on PKI, the public key infrastructure. So what that entailed is the conception and actualization of security by default, which in turn is activated the moment you start installing the cluster. So the first member in the cluster, which is publisher, and the following members, which are the subscribers, whatever their role can be, they can be call processing, TFTP, or MOH. So irrespective, they are all collated in a single file, and once the cluster is installed, the file is being built upon. It's not a static entry, it's a dynamic entry. The moment you add a new member to the cluster or remove a member from the cluster, the IPS is modified on the floor. So what that means is the IP file is there from the beginning, and the moment an endpoint is configured on the cluster, whether that's for auto registration or manual registration, the endpoint is ought to download the ITL file. So the moment you plug in a phone to a PoE-enabled switch port, it does CDP, VLAN, VLAN search to put itself into the auxiliary or the voice VLAN, and then finally, when it gets the TFTP IP address from option 150 from the DHCP scope, it gives out TFTP, and at that very time, TFTP says, okay, here is your ITL file. So that file, once on the phone, tells the phone, these are the servers you can trust. It becomes the very root of trust, or it becomes the initial trust point for the phone to say, okay, I should be trusting only these IP addresses or host names, nothing apart from them. So essentially a phone is now tagged, or it's associated with a specific cluster. So the moment you take out now this phone and plug it into another cluster, that's not going to help, because that phone is not going to register to another cluster. You'll have to remove the ITL, and that is one of the things we are going to cover later on. There are issues with ITL as well, unless it's managed properly, and that's why there is phone view to the rescue. So what that entails is ITL, or security by default, cannot be disabled or removed. It can be temporarily put off by enabling the enterprise parameter, which says pre 8.0 rollback, but then it's a temporary solution. for the permanent, and what Cisco does recommend is only enable it when you're upgrading the cluster, so you can actually roll back and remove the ITL file. Otherwise, that enterprise parameter is best left untouched. So what you can do with ITL is essentially for all type of endpoints, it is valid. Any phone, any soft phone, so it still remains valid. What it does not include, and on the contrary, when you compare an ITL file, the initial trust list file, to a CTL file, a certificate trust list, which is enabled on activation of CAPF and CTL services on the cluster, is that the ITL is a subset of CTL. It's a mini CTL file, but it does not provide you the functionality of actual signaling authentication or encryption. And along with signaling encryption, you do get SRTP, that is media encryption. So ITL is unable to provide you that facility. You still need CTL for the same. And ITL is only limited to Cisco IP phones as of today. So no third-party phones, any third-party phone, although it may be supported on the call manager as a third-party device, but it won't download or recognize ITL because it's a Cisco-specific file. With the overview in view, we'll proceed with the signed configuration file. So we know that the signed configuration was optional till date. That is, Cisco has been providing a signed firmware ever since 4.x. But now the signed configuration file was optional till 7.x, till 7.15. But after that, when 8.0 came out, it became mandatory. With ITL, it is to be there. So any file which is being downloaded, so the first file the TFTP will throw at a phone is ITL, followed by which the phone will reach out to the TFTP server, validate its credentials, and TFTP will do vice versa. It will say, phone, are you the phone I should be trusting? Yes, these are my initial certificates. So it calculates the hash from within the database. Once that is done, TFTP pushes the configuration file, which is the cnf.xml file, and then the firmware files, the ringtones, and all that stuff. So what this does entail is that the configuration file will be signed with ITL, and then TFTP server certificate is used to sign the configuration. Also, the phone ITL file is used to verify the configuration file. That is, every time, let's say you made some changes on a phone, which was already registered to a call manager. The moment you say apply config, or you say save and you reset the phone will still use the ITL file as the very basis of root as trust to say, okay, am I contacting the right servers to download the file or download the configuration? Or are these my call manager servers to which I should be registering in the call manager group? So to that level, ITL enables security by default. You don't have to do anything. It's automatically there for you. It's for the convenience of automatic security. Now, what can also happen is if the ITL file, if it doesn't match the TFTP certificate, then changing the phone configuration is not possible. What that means is, now if at the end of the day, there are ITL files on the phone, and then for some reason, if the ITL file does not have the right credentials for the people, for the phone to connect to the server and download the config, then the phone is stuck. It pretty much cannot do anything. You just have to either remove the ITL file or troubleshoot the issue. So ITL becomes the very basis of downloading anything and everything. Now the next thing we want to cover here is the phone URLs, introduction of HTTPS version of phone URLs. So this is again something which came with 8.x, and what that means is this is used by default for secure phone models. I'm sorry, how did that happen? Okay. So now there are HTTPS versions. So the moment a phone is a secured phone, that is, there is CAPF enabled, ideally it is supposed to use the HTTPS protocol for downloading any configuration or talking to the TFTP or for any EM service or any other phone-based app. So what that includes is from authentication to directories to idle timer to information, messages, and services. Now, security by default comes in with trust verification service, which verifies the HTTPS certificates. So what happens is, the moment a phone has an ITL file, how does that phone know whether to contact the server and understand, okay, is this the server I should be contacting? And if this is the server, what should entail? So the trust verification service is running at the back end, which is actually security by default. So it's a service which runs in the background and enables security by default. So when the phone reaches out to its TBS server, which is the default assigned server, it cannot be changed. It's dynamic in nature. So for some, it could be the TFTP. For others, it could be the default call manager, and so on. So the TBS server becomes the root to trust against the keys or the signature in the ITL. The phone reaches out. It says, TBS, is this? If this server is going to contact me, am I allowed to contact it? Or is it allowed to contact me? The TBS server replies yes or no based upon what were the contents of the ITL file. And based on that, the phone goes ahead with an ACK. Yes, I will go ahead with the transaction, or a NAC. No, I decline the transaction. You're not in my trust list. So there are some considerations to be made when it comes to the specifics of the cluster. So there are host names. So since all the certificates, any PKI model is based on common name. So common name becomes the root criteria for any PKI, and such is the case with ITL as well. So make sure the host name in the URL is the same as what is the host name of the server. So if the publisher is being the root for extension mobility, for example, so you have extension mobility service enabled on the publisher and you're not using any kind of server load balancing, then that server name should be appropriately updated in the enterprise parameters for extension mobility and for other phone services. So there is a temporary workaround though. If a phone is not working with the HTTPS URL, of course you can switch back, even on a secure phone, to a regular non-secure, non-SSL enabled URL, and that should enable the phone to talk back to the server, but that would not be an idle situation. So this is exactly what I spoke about in the last slide. So the first step is the phone begins SSL handshake with the web server. The web server presents its SSL certificate. Then the phone says to the TBS server, whichever that is in the cluster, is this server to be trusted? If the reply is yes, then the phone goes ahead with the transaction. So this is essentially security by default in action. Trust verification service is the backend real player for security by default. That is security by default running in the background behind the scenes. So this is exactly how a transaction would normally occur, and this is usually when you start with SSL handshake, you're using a secure URL. In case that is not working out for you, make sure you turn back to the non-secure URL on that endpoint, or just do a bad update for the endpoints which are not supporting it yet. So what about the phone web server? So from previous versions of Call Manager, from what I can remember from 7.x onwards, it's disabled by default for good. There were too many issues I have seen in practice in the field that people were worried about the phone web server being open for exploit or attacks. And what it was being typically used is for, say, QoS statistics, and then for logging onto the phone remotely to see what are the phone statistics, say for troubleshooting sake. You can log into a phone using the web IP address, just type in the IP address, and you're there if you know the IP address of the phone. So that's an exploit right there. If you can log into a phone's web server, you can get a lot of information from there. and that information can be used very well by a seasoned hacker to log in or launch an attack against the cluster or against the whole UC environment, because a lot of details are there. The switch port details are there, the default router is there, the call manager call control is there, TFTP server is there. So a lot of information is exploited right then and there. So what if you disable it? If you disable it, this will affect remote control, paging, and inventory applications. And in case you want to enable it cluster-wide, Cisco has empowered you with a cluster-wide parameter under enterprise parameters. You have an option to enable the enterprise phone configuration. So if you go to System, the first menu on Call Manager, under the drop-down, you should be able to see that right there. And once you enable it, it applies to all the phones all across the board. So with this background, I would like to pass on the ball to Stephen for the various common issues which they have encountered in the field and which were resolved, which were helped by the use of PhoneView.
Thanks very much, Shakil. Appreciate your input there, and I'll try and keep the same level of detail and benefit in terms of information. So basically, Shakil's given you a great background in terms of security by default here to stay. Effectively, it's something that wasn't really part of UCM at the beginning, so everybody effectively needs to understand and learn more about the kind of default level of the security enabled within the cluster. Now, as with any change, there's obviously some impact to that, and that's really the main theme for this presentation. So, as much as it's great that people are now being effectively educated in terms of security by default, there's quite a lot of detail to this, so we'll try and kind of cover it as best we can. And as part of that, I'm going to cover some common issues that we find, and in terms of customers that we've assisted with when they've hit problems relating to security by default. And as I say, it's the same with any change. There's always some knock-on effect. Now, in terms of what you should see in the slide deck right now, there's some common things that your users may discover. For example, the actual URLs on the phone may stop working. So therefore, things are dependent on those phone URLs, such as the directory, the services, even the help button may stop responding on a phone that has an issue. Now, the nature of the issues that typically happen is the ITL file contained within each handset. For some of those phones, sometimes it's a very small percentage, sometimes it's a very large percentage. They can get out of synchronization with the certificates in the cluster. So as Akhil demonstrated, there's TFTP and TVS certificates. Now, if it's the TVS certificate that is out of sync and the phone's unable to match any of the TVS nodes that are running on the relevant subscribers, then those services typically fail. So you might have end users reporting issues that they can't log into the phone because the services button doesn't work. Now, the thing that's quite subtle about that is, ironically, all the phones still register. So it's not the most obvious issue that may happen, and it depends on the scenario. If you're not using extension ability, the services or directory very often, and it's not part of your test procedure when you're doing your migration, it's something that can be easily missed, unfortunately. So it's something to look out for and validate as part of a test. Now, there are some steps that you can take to mitigate some of this. I'll cover them in a little bit more detail in the next slide, but fundamentally you just need to be aware that that's one of the more common things that may happen. Additionally, because of the web server that's built into the phone, and there's a change in its default setting, effectively, it was normally enabled consistently in all the previous versions of Communications Manager or Call Manager in terms of old school terminology, all the way back to the very first version. So 8 really is a significant change in terms of disabling the web server. Again, it's something that's maybe not used very often. It might just be certain applications or certain tool sets that are dependent on the phone's web server. So it might not be very obvious that change has happened. So you just need to be aware of that and if it has an impact. Now, the third point here relates to changing the phone configuration. Now, because the phone's configuration file that comes from the TFTP server is also signed, that's part of that mechanism to kind of prevent rogue configuration files getting onto the phone and potentially compromising it. If the phone does get out of sync, although it's registered and online and able to make phone calls and can take line configuration information, the actual kind of base level phone configuration that includes things for whether or not the phone's web server is enabled, the URLs it should use. There's probably about 40 or 50 kind of settings that sit within that specific file. They are no longer trusted, unfortunately. Therefore, those parts of the phone's configuration are unable to change. So again, it's something that's quite subtle. It might not be very obvious. You might only realize that that issue occurs somewhere down the line. And these are the things that, as I say, we've experienced with other people and maybe why they've found the problems. In terms of the phone configuration not changing, that's actually really complicated to solve sometimes. It's not just something you can typically change something in Call Manager in terms of its configuration and push it down to the phone anymore because it doesn't trust any new configurations. So unfortunately, you can end up in a catch-22 scenario, and in that case, it might be that the actual authentication URL that the phone uses to be able to talk to the phone remotely and do something with it, maybe delete an ITL file remotely is one of the more common tasks to solve this problem. Because you can't change that authentication URL, if that URL was secure to begin with, you're locked with that setting. And the same thing applies for one of the more common techniques that we've found people use to try and delete or clear out ITL files and resolve issues or prepare for migrations and significant changes is the setting that Akhil was referring to, which is the pre-Call Manager 8 rollback parameter. So a lot of people use that configuration as part of upgrades. We've even seen some people that use it and leave it turned on permanently, which is absolutely not recommended. It's really something that's just a temporary setting, for the purpose of clearing out the files. But here's one of the catch-22s is if you have a phone that has an ITL issue and it doesn't trust the configuration coming from the TFTP server, you cannot actually tell the phone to remove its ITL file using that setting. So, you might find that you've got, say, 10,000 phones all registered happy, and you're upgrading firmware or doing a software upgrade on Call Manager itself, and you set that rollback parameter to make sure the ITL files are cleared out, and so that when the software upgrade or the change happens, that they'll pick up the new settings. The problem is, as far as you're aware, maybe all those ITL files have not been removed from the phone during that transition, because if you had, say, 5 or 10% of phones that are out of sync in terms of that TFTP certificate, then unfortunately they won't take that instruction to remove their ITL file, and they'll just remain with their existing configuration. So again, it's one of these catch-22 scenarios that you need to be really careful about. And I'll go on to how to kind of avoid and prevent issues with that. Certificate management. So this is one of the things that can happen because of the nature of ITL files. There is no central certificate repository to work from. In the case of if you had actually chosen to enable security, fundamentally using CTL files and the USB keys that you use to store those root certificates. So because that doesn't exist in a default mechanism, it's self-signed certificates. So unfortunately, certain changes on the nodes can cause those certificates to regenerate. So, server host names, various parameters, NTP servers, things like that. Even the case capitalization of the host name, if it's wrong or different, after an upgrade or a migration to UCS, etc., it can knock out those certificates. Another factor in terms of considering self-signed certificates and the impact of them changing is if you have more than one TFTP server, there is actually a certificate synchronization mechanism within Communications Manager nodes, And there's anywhere up to 20-minute delay between synchronizing that information. So if you've got more than one TFTP server and a certificate's regenerated, maybe a TFTP server, a TDS server, has a parameters change as part of an upgrade of a new certificate, it can actually take or be a difference of up to 20 minutes between the information that goes into the ITL files for each TFTP server. So if you're reading some phones may get the old certificate when it's next update, and other phones might get the new one because it depends which TFTP server that they're associated against. So there's a lot of subtleties that it really is worth getting to understand in terms of those things that can cause some issues. So I'll just move on to talk about some of the recommendations that we give to customers to basically minimize or eliminate some of these problems. So in terms of doing migrations and upgrades, there's obviously a really big incentive with Cisco at the moment in relation to the Drive to 9 program. So if anything, there are going to be a lot more upgrades and migrations because there's a lot of commercial and tooling incentives and assistance that's available. There's a lot of additional resources that Cisco have put together to make upgrading to Communications Manager 9 and obviously greater versions as they release. So I guess upgrades are probably going to happen more often. So therefore, it is really important to think a bit more detail about the certificates and the impact of security by default. So what we typically recommend we've listed here, which is the actual URLs that the phone uses. And these things you typically just do on a temporary basis. It's not something you would typically do long term. You need to kind of consider the overall security posture, and you really want to leverage the benefits of security by default. So these are just temporary transition settings to use to minimize the impact of an upgrade. So for example, if you go to non-secure URLs, and you need to make sure you change the port 8080 as well. In particular, if you do that with the authentication URL, it means that the phone's web server can still authenticate, which also means that you want to make sure that you enable that phone web server as well, because it's obviously turned off by default now in version 8. So during that migration phase, make sure it's turned on. And by doing that, it means, from a tooling perspective, you can always control and access your phone. So it doesn't matter, even if it's unregistered, which does happen, it's very rare, but it does happen, you can still remotely control that device. So that's, the kind of preventative things. One other part, it doesn't happen as often, but when it does happen, it's quite painful, unfortunately, is the actual phone settings. Some customers, typically just in public phones, it's usually not across all handsets, but sometimes that is the case, but it's fairly rare. But if you do set the phone settings to restricted or disabled, and the phone does get some form of ITL issue and gets out of sync, then unfortunately the only way to resolve the issue with that phone and get the ITL file updated again correctly is a factory reset. And that's something that cannot be performed remotely. If it was technically possible, we would have found a way to do it and obviously implemented that. But unfortunately, it's the one thing that you have to do physically. So therefore, as a preventative measure, understanding and changing and ensuring that all your settings are appropriate and correct before the upgrade. It's a bit like when you do an upgrade and you make sure that all the phone software levels are ready before you upgrade. It's one of the things to consider to basically ensure a smooth migration. Obviously, as we're trying to, help with in terms of the webinar series, is you really want to get to know the Cisco Unified Communications security mechanics better. It's something, as Akhil mentioned, that's here to stay, so you're going to have to learn about it, whether you choose to or not. And obviously that's why it's been very good to tie up with Akhil, because it's given us great input in terms of the report, which I'll show you a little bit of in the demo. And that's really, again, further education and information on your target system in relation to its security configuration. So that helps to educate you in that space too. And actually, the last point is probably the best solution, ironically. So rather than being careful, completely careful and preventative, if you actually migrate to choosing security certificates rather than depending on the self-signed certificates, which is basically deploying CTL files. It's probably the most consistent way to ensure that you've got complete control of the certificates and security mechanics of your cluster. You don't have to enable authentication or encryption. You can leave them to default if it's not something that you require, but it just gives better control, and that ties in with understanding more of the security mechanics. So really, that's the kind of key recommendations, it's one of those things that you really need to just make sure you understand the implications of this new feature. So, in terms of useful resources, obviously there's Akil's book, which is an excellent reference, so that you can get into whatever level of detail that you need to. There's some videos that are useful, as I think was already asked earlier. We'll be sharing these slides. You just need to email us and we'll send you a copy out at sales@unifiedfx.com. And some of these videos, for example, we've got a video that shows how to manage ITL files. We've actually, the next session, which is next week, covers that in great detail. So, you'll get all the information required from that session anyway, but that's a nice quick summary on how to consider managing ITL files. And there's some introduction to PhoneView. One thing above anything is there is an excellent document by a chap called Jason Burns, which is in the support community. If there was ever a single point of reference that you really needed to try and understand as best you can, it's that document. So that link there is probably the most important of the set. And then the last kind of piece before I kind of go into the demo, and I'll probably cover portions of this report. We'll see how we are for time. But basically, because we've been trying to kind of not just delete ITL files, which isn't really that technically challenging, especially if you're careful and set your cluster up correctly, it's actually understanding the overall security posture and compliance of your environment, along with the new functionality with security by default and managing its impact. So the way that we try to kind of educate and inform people is through this new feature, which is the ability to generate a report from our product PhoneView, which is what we class as an endpoint security and health check report. It's really a compliance document as well, so that's kind of where this series of events is kind of leading to, is fleshing out that kind of consideration. So I'll go over the report in a bit more detail, but just to kind of point out that it's linked quite carefully to further information in terms of what Akil provides in his book. So it's a great introduction to some of the key concepts, and then you can understand them in more detail. So that leads us on to the demo. There may be a few questions. No, I think we're no, I think it's fairly quiet at the moment. But if you do have any questions at this stage, please submit them. We'll cover any at the end, and we'll post them along with the recordings as well. So if you just give me a second, I will swap over to my desktop. Okay, so we have PhoneView up and running, and we've got some phones in there. I've already set it up previously. And what I'm going to take you through is two key elements. The first we call the endpoint scan, and one of the things about security by default, it's not just the fact that you might have an issue and maybe not even fully understand the issue completely in terms of how it happened. That's quite a mystery in some occasions, because it's maybe a software defect or just circumstances. That's one problem. But the thing is, once it has happened or something has happened, you really want to know to what scale and effect that's really affected the system. So to be able to do that, you really want to gather a lot of information on the endpoints. And one of the key features that we added to our product is a thing called ITL status. But there's a lot of other information that we can gather as well. And the way to make that nice and simple and to kind of analyze that data is through the scan. So if I go to the toolbar here, I just click scan, opens up the scan wizard. There's some initial information, just giving you a bit of background in the scan procedure. In particular, there's a new feature, which is the TBS status, which is a kind of second metric that you can use to detect ITL issues. But that's something we'll go over in a bit more detail in the next session. This case, I'm going to select all the devices. And I'm going to leave off the TVS status for now, and we'll just gather data from the phones. So it's quite simple. I click Next, and there's a series of data gathering exercises from multiple sources that's happening right now. It's obviously just a small lab system, so it won't take long to do. It's something that's probably best to run out of hours, to be absolutely careful. Just watch your CPU load on your publisher when you're running it. It can have a bit of a load on some people's systems. But primarily, it's going out to the phones and it's gathering data from them. And it doesn't take long to do, but it's actually just analyze that information. And what you get at the end is effectively a summary of the information that's gathered after it's been analysed. There's a number of key areas that we cover, firmware versions, SSH, etc. But the ones that really relate to security by default are ITL status, TVS status, and remediation. So I'll primarily talk about ITL status. Now, deliberately, we have a broken phone in our lab, and this has actually been flagged up. So it's failed that particular validation point. And what it's also done is, because it's gathered things about whether or not the phone server, web server's enabled and other parameters like that, it's analysed it and it's determined that actually, good news, we can fix any issues remotely. So that's the remediation section. So it's flagged red because you're going to have to fix some issues, but primarily it's flagged that it's remote, which is great. So you don't have to get your shoes on and delete those ITL files, for example. And then there's like a breakdown of how many phones of what type of issue. So what I can then do is leave this little tick box on here, generate report, to basically find out more detail. If I click OK, as a default file name that's populated, it's date timestamped. I'll just click Generate Report. And actually, I've got one I opened I did earlier, so I'll just use that one. So there's the PDF document. And if I go to the top page here, there's the report that's generated. So this is a consultant level document. It's effectively written by UnifiedFX and ACL for the purpose of understanding the endpoint security of the target system. So there's quite a lot of information in here, but we've kept it as concise as we could and really to the point. And again, it leads into the book to find out more. But what I'll cover at this point is, you can see in this table here, it's basically the same table you saw a moment ago at the end of the scan. It's got the fail notified against ITL status, and we've got some remediation recommendations. So if I go to the table of contents and I go to the ITL status section, so what you can see here is we've given you a bit of background in terms of security by default in the document. Some further information that you can go and get. And here's a quick summary of the ITL information that was gathered. So again, just a small lab with just a few phones that support security, ITL files, but one of them has an issue, this 7961, and we can see that broken down in the table. Now, the thing is, not everybody would immediately understand what an ITL status kind of means. So what we did is we put this table together, table 8, which includes a short summary of the different ITL status messages that you can get for phones, and effectively what you need to do, what the net effect is. So for example, if you get trust list update failed, it does mean it has a problem that requires the ITL file to be deleted. So obviously that's kind of informed. There may be other messages, no ITL installed, no trust list, etc. But that's depends on your scenario. But we'll cover that in a bit more detail in the next session. And then broken down is the actual ITL status exception sample. So it's like a small list of up to the first 5 devices that it finds with an issue. It's one of those things, we don't want this to be a huge report with pages of just tables and data. We've kind of kept it as concise as possible so you can get an instant view if there is an issue and a perspective on the size of that problem. You can export huge amounts of information as well from PhoneView in terms of spreadsheet, raw data, so you can dig in deep if required. So if I carry on, we've obviously got TVS status as well, and say we'll cover that in the next session. But the final one that relates to security by default is the remediation. So because that scanning operation gathered a whole bunch of information on all the endpoints, and it knows things such as if the phone's registered or not, if the web server's accessible, even if it can authenticate to the phone's web server, because remember, if that TVS certificate's out of sync and the phone's using a secure authentication URL, then you can't actually remotely control the phone. So we figure all that out, including the phone settings, if they're restricted or disabled, because, you know, no matter what you do, you're going to have to physically go to that phone. So by analysing that information, we can give it a very short breakdown just to say here are the number of phones you need to fix and how you need to fix them. If you did have to physically go to any phones because their settings had been disabled or restricted, the spreadsheet that PhoneView can export for you actually tells you where those phones physically are. You know, all the information such as device pool location, the switch they're connected to, even down to the switch port. So, you know, some companies keep track of all that information literally down to the person's desk. In fact, we can even link to the person's email address that uses that phone as well. So all the data is there for you to utilise to maximum benefit.
With PhoneView from UnifiedFX, you may never need to send an engineer to site again. www.unifiedfx.com